Alright, so hopefully you guys had a chance there to factor your question there. So we were working on number 2 here, and I apologize, it didn't save, I don't know what happened, but it just didn't save my inking here. So I'm going to rewrite what we got up to. So here we were at 0 is equal to x squared plus 3x minus 54. Okay, so I asked you guys in the previous video there to factor. So what you guys would do here is we have a product of negative 54 and a sum of positive 3. So we can rewrite this middle term here if you guys can think about that. So what two terms would give you negative 54 and then a sum of 3 would be positive 9 and negative 6. So we write this middle term here. So we have 0 is equal to x squared plus 9x minus 6x minus 54. Then we group the first and second term and then the third and fourth. We'll pull that common factor of x and then negative 6. So we have x plus 9. I'm going to continue up here. And what we're left with is x is equal to plus 9 and x minus 6. And then from there we set each of those factors equal to 0. So we have x plus 9 is equal to 0. And then moving 9 to the other side, we have x is equal to negative 9. So it'll be our first one, and then our second one there we had x minus 6 is equal to 0. And we find that x is equal to 0 there. Okay. So now let's check to make sure that these work. So first what we'll do is we will find the restrictions if you guys didn't do that already. So your restrictions there. So that, if you guys remember, your log cannot be equal to 0 or any negative number. So what we'd be looking there is, so first we'd have, I guess you guys could set each of those factors equal to 0. So we'd have x minus 3 is equal to 0 and x plus 6 is equal to 0. Moving those numbers over to the other side, we have x is equal to 3 and x is equal to negative 6. So at these points here, these ones are going to make our value 0. So it cannot be 3 and it cannot be negative 6. And remember, so if we put in, we're going to be using, our restriction must be greater than 3. If you guys remember that, because 3 would give us a 0, so it cannot be equal to, and also can't be anything less than that, because say if we put in negative 6 into that first one, it'd be negative 6 minus 3. That would give us a negative 9. So we can't have anything in between 3 and negative 6 as well. So you go with your bigger value. So your restriction is that x must be greater than 3. Then you guys can compare. Well, is our first one, we have x is equal to negative 9. Is that right? And no, that doesn't fit the restrictions. So because negative 9 is less than 3, so that actually doesn't work. So we can already exclude negative 9 there. And then our next one we check is x is equal to 6. And then check that with your restrictions. So x is in fact greater than 3. So then what we can do is we'll plug it in and verify. So I'm just going to erase our left-hand side there. So hopefully you guys have that down by now. Alright, so to verify here, we're going to plug x is equal to 6 into the original log function. So we have log base 6 of 6 minus 3 plus the log of base 6 times 6 plus 6, and that should be equal to 2. So here we got the log of base 6 is equal to 3 plus the log of base 6 of 12 is equal to 2. Then we'll use our product rule. So we can write, this will be m and n, so we can use that, and it'll be 3 times 12. So log of base 6, using that product rule, 3 times 12 is 36. That is equal to 2. And if you guys look at log 636, this actually, if you guys were to put this back into exponential form, I'm just going to write this off to the side here. So we'd have 6x is equal to 36 That is this log in exponential form. And so what value of x would make 6 equal to 36? And that in fact is 6 squared, so that is when x is equal to 2. So 2 is equal to 2. So that is true there, okay? So now let's move on to the next page there. I'm just going to scroll on down here. And so one thing I want to make a note here is that we can also solve exponential equations algebraically by taking the logarithms of both sides of the equation. So this is one that we can add to our previous statements. So here, suppose we had L and R, they're just arbitrary numbers that are equal to one another. Then what we can say is that if we take the log of base C of L is equal to log base C R, where C, L, and R are all greater than 0, and C can also not be 1. Okay? So when you do this, then you would apply the power law for logarithms to solve for an unknown. Okay? So we'll look at some examples of that, what this actually means here in just a second. So one last note that I want to make is that you can also solve exponential or logarithmic equations graphically, like we have studied in other sections and units. So what you do is you would set each side, so you'd have, say for example, let's look at this bottom one here, or this first example. What you do is you set each side equal to y, so you'd have y is equal to 5 to the power of x, and y is equal to 200. You would graph it and see where these two intersect. Or what the other option, which I also did show you guys, was you move everything to one side and set it equal to 0. So you'd have y is equal to 5 to the power of x minus 200, and then you'd find out where y is equal to 0. And wherever it crosses that x-axis, that is in fact where our solutions are, okay? So I'm just going to erase this and we'll move on to some examples. So we're not actually going to do any graphing in this section, but you guys are more than welcome to do graphing if that is your preferred method. So, but you guys have seen that many times throughout this whole course, so I'm not going to show you that way. I'm just going to show you how to solve it algebraically, okay? So for this first example here, we have 5 to the power of x is equal to 200. So using what we said above, that if we have two numbers that are equal to one another, we can rewrite them by taking the logs of each side. So what we'd have is the log of 5x is equal to the log of 200. Now this one is usually if you can't think of maybe a way that we can rewrite 200 as a base of 5. You guys did trial and error earlier, so here is another example of what we can do, and why I guess that's why we would do this. So here's another option of I guess instead of doing trial and error or graphing. So we take the logs of each side, and this one we just assume it's a base of 10. So we just kind of leave that one blank there. So we just leave it as it is and just write it as the log of each of those sides. Okay. So what we can do is, as the next one says, it says to apply the power law for logarithms. So if you guys remember, that takes your exponents and writes them out front. Okay, and there's no exponents for our right hand side, so we'll leave that one as it is. So here we will have x log of 5 is equal to the log of 200. Alright, so from there we want to solve for x, and if you guys remember, what the I guess what the power rule does is that when you bring out that exponent, these two terms here, your x and log 5, those are multiplying. So what we can actually do to solve for x is we can divide by each side by log of 5. Alright, so then what we'll have is x is equal to the log of 200. Divide that by the log of 5. And from here, we can't actually really do much of anything else. So what you guys can do though is, using your calculators, you're going to put the log of 200, divide that by the log of 5, put this into your calculator, and you should get a value on your calculator there. So make sure, take the time now, and you guys will probably just have a button that says log. This button here, that one is always for base 10. unless if most calculators do not give you will not allow you to have a different base. So say if you even had log Cn, that's fine. Your C would be 10 there, but I think most of them usually just give you just the log button like this, and just know that whenever you guys do that, it will only do for base 10, okay? So make sure, put those into your calculator, try it out. And then what you guys should get is, if you guys want to see each and individual value, I can surely put them in so you can see what you get in your calculator. So you should, if you put log of 200 in, you should get 2.3010299996, and it goes on. It's a repeating decimal there, okay? And then for your denominator, the log of 5, that is equal to 0.6984700 and ... It goes on. So make sure you keep those numbers into your calculator. Try your best not to round, because you guys have probably seen this throughout your years of math, that when you round, it changes when you're dividing, so it'll kind of influence that value a little bit. So try and keep those decimals in your calculator if you can. And so when you divide these two numbers, we will find that x is equal to, because we are rounding, it should be approximately equal to 3.29. And if you guys want to double check that, put 3.29 in for x, and you guys should find that it comes pretty close to 200 there, okay? So moving on to number 2 there. I'm just going to draw a little nice squiggly line. So here we have 3 to the power of 2x is equal to 7x plus 1. So this one would be probably extremely difficult to think about how to do algebraically through trial and error. And graphing, yeah, that one's graphing's graphing. I find that one is actually not that bad. So, but we're going to practice our logs. So we're going to rewrite each side as a logarithm. So we'll have the log of 3 to the 2x, and that is equal to the log of 7 to the x plus 1. So just like we did before, we're going to rewrite using our product rule. And in this case here, we have exponents in both of these. So we'll rewrite that out in front of the log. So we have 2x log of 3 is equal to x plus 1 times the log of 7. So now what we're going to do is we're going to actually distribute. We have x plus 1 here. We're going to distribute to that log of 7. And you'll see why we do this in just a second. So we have 2x log 3 is equal to x times log of 7. And then we have 1 times log of 7, which is just log 7. And then what we're going to do is, so remember, we're trying to solve for x. So what we're going to do is we're going to move this term over to the other side, because what we're going to do is we're going to group those x's together, and then we're going to be able to pull it out, and then we'll have x by itself. So you'll kind of see how this goes along. So if you're not sure what's going on, just work with me here, and you'll see how kind of magically this works. It actually works out very nicely. So what we're going to do is we're going to get all the x terms onto the other side. So we have 2x log of 3 subtract log of 7. That is equal to the log of 7, okay? So as I was saying here, let's pull out a common factor of x. So we have x times 2 log of 3 minus the log of 7, and that is equal to the log of 7, okay? Then it's kind of looking a lot more like what we did before, so now we're going to divide both sides by this function here, or that expression there. So we have x is equal to log of 7, divide that by 2 log of 3 minus the log of 7. Okay. So from here, you're going to put that into your calculator, and while you're doing that, the video is going to run out, so we're going to switch over to video number 3. So put that into your calculator, and we'll find a value, and we'll discuss the answer afterwards.